Hello everyone. In this lecture, I'm going to talk about other engineering devices. We already talked about compressors, diffusers, nozzles, turbines. So we want to apply the first law of thermodynamics to other engineering devices. The first one is throttling valve. And in throttling valve, basically what is throttling valve is any basically kind of restriction against your flow is called throttling valve. For example, an adjustable valve or a porous plug or a capillary tube, anything that basically restrict your flow is called throttling valve. So what happens, what is the difference between the turbine and throttling valve is that basically in throttling valve, in turbine, your flow energy will be converted into work. However, in throttling valve, that's not happening. There is no work being basically produced or applied to the system. So basically the net work being done on the system, or the network basically, which is the difference between work input and work output, is 0. And if your device is small enough or the process is fast enough, basically you have no heat transfer, and therefore based on the first law of thermodynamics, you only have enthalpy left. So enthalpy at the entrance is equal to enthalpy at the exit, and enthalpy definition is basically internal energy plus flow energy, which is equal for inlet and exit of basically throttling valves. Now, if you have an ideal gas, the temperature stays constant during the process because enthalpy is only function of the temperature for ideal gases. However, if you don't have an ideal gas, or if you assume that your gas is not ideal, you will have a large drop in your temperature. So therefore, these devices are being used in refrigeration and air conditioning operations. You can see here as well, the enthalpy stays the same. With that, I don't mean that basically your internal energy stays the same or your flow energy stays the same. Of course, your flow energy would change during this process. But your flow energy definitely changes during this process. The internal energy changes during this process, but the sum of basically your flow energy and internal energy stays constant during this process. So that's throttling valve. Another type of device is basically called a mixing chamber. So mixing chamber is where basically two stream of flow join together and then make one stream out. So that's a mixing chamber. I mean, you could have more than one outlet as well. It doesn't mean any basically type of chamber that have basically multiple inputs is called a mixing chamber. For example, a T-elbow in the shower basically is also called a mixing chamber. Cold water coming in, hot water coming in as well, and then you have basically one outlet, right? So the thing is basically the important thing that you need to remember from these devices is that the sum of the mass, you need to write the conservation of mass as well. So the mass at, for example, if you look at this mixing chamber, we have m.1, right? And we do have m.2. So the sum of these two, if you add them together, that's going to make whatever is output, right? So m.1 is plus m.2 is equal to m.3. Also, you can write the conservation of energy for this. There is, if you have an insulated system, that there is no heat transfer with basically surrounding, and you don't have any work done being on the system, no kinetic energy change, no potential energy change, then this is what you write for your conservation of energy. The only thing that will be left is basically your enthalpy. So you have two equations, and depending on the problem that you have, you might want to use both equations to solve your problems. All right, so that's basically another device. The third one that we're going to introduce is basically heat exchanger. So heat exchanger is a device that two different streams of fluid coming in, they don't mix with each other, but they do transfer heat with each other. Okay, so there is a heat transfer going on, and for example, you can see this is a very common device in industry. You can see in this picture that fluid B is coming in with high temperature and leaving the system at very low temperature. Fluid A comes at 20 degrees Celsius and leaves at 50 degrees Celsius. There is a heat transfer between that fluid and this fluid, but they don't mix. Okay, so this is called a heat exchanger, and we will do an example on this in the next video.